Okay, so this is a video for Minitab Express and how to use Minitab Express to do Project 2. And so remember in Project 1, you used Microsoft Word to create all of your tables and charts and graphs and whatnot. And then you use the calculator to compute all of your statistics and your linear regression. Well, we're going to use Minitab to do every bit of that and even a lot more than that, because we're going to not just do for one quantitative variable and one categorical variable, but we're going to do for every single variable. And then we're going to do some cumulative distribution function stuff too, and some normal probability plot stuff, some things that we didn't get covered in the first project. So Minitab's just really nice in that it'll do it all sort of quickly for us, or at least we hope so. And if you follow this video and you follow the instructions closely, it will. So in part A, the first thing that it tells us, and I've adapted these instructions from Minitab 17 instructions. Well, the first thing it tells us to do is to copy and paste this list of things. So you would give your group name and the list of all your members in Math 1530 and the project and the due date, all those sorts of things, and you would copy and paste it into the session window if you were doing Minitab 17. But you'll notice that I struck out that set of instructions. That's the only thing that I don't think we can do in Minitab Express, because Minitab Express doesn't let us write in the session window at all. It will only put the output from Minitab in there. It won't let us copy and paste and add stuff or edit stuff to that. So that's one of the differences. So we'll just ignore that, and be sure to ignore that on the rubric too. At one point I'm going to update the rubric so that that's not a required item anymore, but that's not going to be immediately, so you may still see that in the rubric if you're doing this right after we started using Minitab Express, for sure. And then we'll jump to step 1. We want to get our data out of Project 1, and if you've done a good job with your data in Project 1, then that'll be easy. And this one actually this group did a really good job with their table. You'll notice that this is a real table in Microsoft Word, so that's good. I don't want that first column because it's just numbers really, and I'm going to have numbers on my rows here, so I don't really need that. I do need all of the columns that actually have data in them though. So I want to copy the headers if I can, and here this is a really nice table, so I can easily copy the headers. But I definitely want to copy all of my data. And I want to be sure that my quantitative data values only have numbers in them. Minitab will get very mad at me if there's like 2-3 or 2-3 or 2 and 3 or 2, 3. Anything that's not a number in the cell that's in a column that's supposed to have just numbers in it, it's not a good idea. So if you do have that sort of data, you'll want to fix your data first and then copy and paste it. Right now though, obviously I have great data because all of mine is data in this column and all of it's data in this column, and so I can just copy, and I like to do Command C, or on a PC it's Control C, but you can use the icon or you can do Edit Copy. And then I'm clicking on Minitab, and because I'm copying the header rows, I want to be in this cell right here, C1, and the header cell. Now, if I had not copied, if I only had the data and not the headers, then I'd want to put my cursor right here. But I definitely want my cursor right here because I did copy the header rows. And now I'm going to Control V, or if you don't like that, well, actually I'm going to Command V because I'm on the Mac. But if you don't like that, you can always do Edit Paste. So Command V puts all my data in here. I would have gotten an error message if one or two of these cells had problems in them. In other words, if they weren't numbers, and they were obviously supposed to be numbers because the rest of them were numbers. So Minitab would have hiccuped and given me a warning message here. If that happens, just go fix them. If there are only a few, go fix them. And if there are a lot, you probably want to fix them in here before you copy and paste them in here. But make sure all of your data is like it is in here. And then I want to make my headers shorter. So what state were you born in? I'm just going to call that birth state. How many siblings do you have? I'm just going to call that siblings. And rent or own your current residence. I'm going to just say rent or own, although you could do rent or own residence. How old are you? I'm going to call that age. And did you graduate college or university? I'm just going to call that a college degree, because a university degree is often, college and university are often interchangeable. So I'm just going to say college degree. And then we're done with our data, as long as our data looks pretty good. And we'll go back to the set of instructions. For number 2, we want to do frequency tables for every single variable. So I'm going to go up here, and tally will do sort of a frequency table. It's not exactly the same because it doesn't list every possible value between your range of data values, but it's really close. And so I'm going to go in order for all of my variables. And so birth date is the first variable, one variable at a time. I want both counts and percents. I don't want either of the cumulative. And I'm just going to repeat this. So under summary tally, I'm going to do the second variable, both counts and percents. And then I'm going to do the third variable, counts and percents. And the fourth. And the fifth. One variable at a time, both counts and percents, not cumulative, anything. Now I'm going to go back and look at my data and make sure it looks all good. So especially on these categorical variables, I want to make sure that each one is listed only once. So Africa, Florida, Georgia, Hawaii, Illinois, Kentucky. I'm just making sure they're not duplicated. So maybe I misspelled Puerto Rico and, flip the U and the E. And so in that case, it would be listed twice. Of course, I only have one person from there. But let's say Tennessee, I spelled Tennessee wrong once, or I didn't capitalize it once. So if Tennessee is listed twice here, then what I'm going to have to do is I'm going to have to go through my data and find where it's different. I'm good there. For quantitative variables, I should definitely be good, unless I have some missing values, and then I want to make sure that the missing values are where people actually didn't answer that question. So if I have any asterisks or values that say missing, I want to make sure that that's right. Here, notice I do have a problem. So this data wasn't absolutely perfect. It was really close. But I do have one variable that probably has a space in it, because look, they don't look any different, and we wouldn't be able to tell if it has a space in it. And so what we'll want to do is we'll want to double click on each of the rents until we find one that has a space in it. And oh, look, there it is. So I delete that space. And then I want to go back here and I want to delete this variable because it's wrong, because it has rent twice. And then I'll go back and I'll redo tally for rent and own. And now they're sort of slightly out of order, but I guess it's not a big deal. And now I have one homeless, 9 own, and 20 rent. And I'll look at my other variables. Good. I only have one row of no's and one row of yeses. And my ages look good too. So everything looks good there. And I fixed all of my data, and I know my data is fixed now. And I can move on to number 3. Number 3, we're going to do summary statistics. And we're also going to include in that histogram, dot plot, and box plot in the summary statistics. And this will only work for our quantitative variables. In the data set I'm using here, there are only 2 quantitative variables, but you may have many more. So I'm going to do summary descriptive statistics. And then for each quantitative variable, and you'll notice that the quantitative variables on mine have the blue icon and the categorical variables have the green icon. So only the blue icon's what I'm going to use in this. I'm not going to group by any variable, so don't use this optional one. And then I want to add some statistics. I'm going to add interquartile range and the mode and the range and skewness factor. And then I want to display all 3 of these. And I'm going to do repeat all of these steps for every quantitative variable I have. So there is my siblings variable, and now I'm going to do the same thing for age. So age, and I have to add these things back every single time. So be sure to go in there and recheck all the stuff that you need to check. And then OK. And then I have my age, and it gives me the box plot, the dot plot, the histogram, and all of the statistics that I need. And so mean, median, mode, standard deviation, range, all of the quartiles and the interquartile range are all given here. Plus it gives a couple of other things that we didn't have in Project 1. So you'll be able to compare all those things when you go to do the report. And then the last thing that we want to do for quantitative data for each quantitative variable is the bar charts. And so graphs and bar chart. And then we want to select mean. Well, mean and other function, but really what we want is the mean. And then we want simple. And so then we're going to select our quantitative variable, and we do need to choose one categorical variable. So choose a variable that you want to use, but you're going to have to use it for every time you do the bar charts. Use that one quantitative variable. I don't think it'll let us do birth date. Let's do college degree, and then OK. And so you see the bar charts, and you may want to look back at chapter 3 to interpret these bar charts. So does that mean that these two variables are associated, or does that not mean? Look at their heights. Are they different? Are they different enough? And then again, we're going to repeat this for every quantitative variable we have. So that's siblings. We want to do this again, selecting all the same stuff for age. And remember that we selected college degree before, so we select college degree this time as well. And now we have a different bar chart for age versus college degree. So siblings and college degree, and then age and college degree. So that's our bar chart. And now we want to move on to do something with the categorical variable, the pie chart. And so graphs, pie chart, and we're going to repeat this for every categorical variable that we have. And so we'll do, and it's not going to let us do birth date, because birth date has a lot of data in there. It has more than 12 options for where you were born, what your birth date was. So we actually have to skip, if we have too many, we have to skip that one. We can do rent or own, because that's just yes or no, and we can do college degree, because that's just yes or no. And then for display, every time we want to do decreasing size. And so that's our rent or own. And then we can also do college degree, decreasing size. And so, be sure to do this one for every single categorical variable you have, unless there are more than 12. So that's the only time that you can skip. And then we move into part B of the Minitab, and the person who's doing the Minitab should do the whole thing. So just keep going through this. It shouldn't take too long. So we want to select regression and then simple regression. And you'll want to use 2 of your categorical variables, and here we only have 2. For the predictor, that's your X variable or your explanatory variable. That's the one that comes first. So here, age is sort of set. It's predetermined. I'm going to choose age first and then number of siblings. Now, I guess an argument could be made for number of siblings than age, but I don't think you can really change your age after you're born. It's possible that your number of siblings can change after you're born, though, so that's why I'm using it as the response, but I guess an argument could be made to go the other way. And then we just do OK here, and that's going to give us a whole bunch of stuff. Number 1, it's going to give us a scatter plot, but it gives us regression equation and some coefficient stuff that's a little maybe difficult to interpret. And then we also want to compute the correlation coefficient. So step 7, we go back to regression and correlation, and we select the same two variables. It doesn't really matter the order here. And Pearson correlation, that's the R value, the Pearson correlation coefficient. And then we select OK, and that gives us that. And then we want to do a probability plot. But for all of Part C, all 3 steps of Part C, we basically want to look at our quantitative variables and see which one is the most normal. So let's go back to our quantitative variables. This one's not all that normal. And age is not all that normal. Age definitely looks like it's got a right skew thing going on. Siblings looks a wee bit more normal. Not a whole lot more normal, but a wee bit more normal. So I'm going to go with siblings. And again, this is sort of a judgment call. But now that I've made this judgment about siblings, everything that I do in Part C is going to be based on siblings. So I want to construct a normal probability plot for siblings. So I'm going to go to graphs and probability plot, and I want to click on simple, and I'm going to do siblings. And there is my probability plot. And then it gives us some stuff down here that may be hard to interpret because we haven't done hypothesis testing yet. But basically, our alternative hypothesis is that it's not normal. And so that's the thing that we might be able to prove, that it's not normal. What you'll want to do is look at the data values in the report and try to interpret to see if this is a straight line. So the blue dots represent our data values, and the red line, if all of the blue dots were on that red line, then we would have a perfectly normal distribution. But we want to know, is it straight enough? Are our blue dots following that red line closely enough to say that it's approximately normal? And this one's actually kind of iffy because the dots are pretty close to the line, but again, especially with this dot right here and this dot right here, I think they're kind of pretty far away from the line. So I would lean towards saying this is not a normal data set. And you may want to, go back to the histogram too and look at the histogram too to say, this is not a normal data set. But we're going to go ahead and pretend it's normal because it's the one that we have that's the most normal. And so that actually the next step is going to be in line with pretending it's normal. So we're going to compute z-scores for our siblings data. And we do that by selecting the data up here on the menu bar and standardize. So that's going to give us the z-scores for our siblings. And it says the method of computing the z-score, or the method of standardizing, subtract the mean and divide by the standard deviation. That's exactly what we do to compute z-scores, so we're good with that. So we say OK. And this makes a new column for us. This C6 is a brand new column that says standardized siblings. And if I'd standardized age, it would say standardized age. And then it gives us all of those z-scores in that column. And we can just scroll down and look at all of those z-scores. And then the last thing that we want to do is we want to do a cumulative distribution function. And that may sound familiar, CDF, if you have done your Chapter 6 videos yet. So CDF, normal CDF, that's exactly what we're doing here actually. So let's go back up to our siblings descriptive statistics, because in order to do this we need to use the mean and the standard deviation and the quartiles for our siblings. So I'm going to actually just take a little picture of this, but you might want to just write it down if you don't have stuff that will take pictures. The next thing that we want to do is probability cumulative distribution function. Cumulative distribution function. And then it wants us to put a single value in. We're actually going to compute the probability of being less than Q1 and more than Q3. So we want our single value to be Q1 at first. So our Q1 value is 2. And then we want to put our mean in here, and that's 4.1333. 4.1333. And our standard deviation, 2.2702. 2.2702. And of course, your data will be different. So your data may have a different, will probably, almost certainly, unless you're the group that I'm using their data, be a different mean and standard deviation for your most normal data set. And it will have a different Q1 that you're going to stick in here. So, and then we just say, okay. And so it's run the normal CDF for our Q1 value of 2, and the probability of being less than or equal to 2 is this 0.173687. So that's what it gives us out. And then we want to repeat the process for Q3, so we're actually doing 2 different CDFs. And so we go back to the instructions, because I keep forgetting where that's located. Okay, probability cumulative distribution function. And then our single value now is 5.25. And our mean is still 4.1333, just like it says under Descriptive Statistics. And then our standard deviation is still 2.2702. Okay, and that is pretty much all of the steps. The last thing that I need to do is save the file. And so I will do File and then Save As. Okay, and then I will name it Project 2 underscore Group Ellen, or whatever your group name is, and click Save. And then, so you want to go back through, because this is what I'm going to check on the rubric. Oops, we want to delete this, don't we? Because we said we weren't going to actually be able to do that. So, boop, delete. And so we'll check to make sure that we have all of the graphs. Our scatter plot should be here. Our probability plot, our histograms, and those will be under Descriptive Statistics, as will our box plots. Histogram and box plot. Our bar charts. And again, we have histograms and box plots for each quantitative variable. We have bar charts for each quantitative variable. We should have just one scatter plot, just one probability plot. We should have pie charts for each categorical variable, except for those categorical variables that have more than 12 categories. And we should have, it doesn't list it here, but we should have tallies for every single variable. And then we should have z-scores. Oh, it does say frequency tables here on number 3. And it also says descriptive statistics, and those descriptive statistics are one set of descriptive statistics for each of the quantitative values. We should have regression analysis, which is also under simple regression. We should have correlation analysis, and we should have our 2 cumulative distribution functions. Well, we should have, exactly 2 cumulative distribution functions. And so once you've checked all of that, load it into the Dropbox. Make sure it ends with .mpjx, x being Minitab Express, and then re-download it and make sure it has all this stuff in there. And that's it.